Hi, and welcome back to the Radio Mechanic. In a previous video, I had promised to explain why I thought it was a nice idea, or a good idea, to have some of these old school analog voltmeters laying around. Now this just happens to be 3 of the 8 that I own. And people say I'm a little obsessive. Probably am. Let's start with number 1 here, a real simple one. This one has a 6,000 volts AC or DC input. This one has a 5,000 volt input. Let's see you find that on a modern voltmeter. If you've got to do any high voltage work, linear amplifiers and such and so on, you can use these things directly as long as you stay away from the leads. Safety last, set the meter, hook up your leads, leave everything alone, and then turn on the power. Don't be handling the test leads, because the actual breakdown voltage of the test leads here is probably only a couple of thousand volts, so you want to keep everything separated. However, you can measure directly 5,000 or 6,000 volts with these guys. But wait, there's more, and we'll show you. Okay, in this example, famed street squirrel Ricky Racer has gone out and bought him some fancy frog lights so he can doll up his 1971 Pinto and impress all the boys. Because after all, you got to have a good frog light if you're going to go out frog squashing in there in the springtime. Now, I don't condone that. I'm just saying Ricky and the boys like to do this after a few of the cans of their favorite beverage. So Ricky wires up his new frog lights. And he's got a 12 volt battery over here. Of course, Ricky doesn't put a fuse. Normally you'd have a fuse here, but Ricky's kind of frugal. Puts a switch in. Got his frog light. And down here, he's got the ground. That's represented by the car body. Most of the time when you have an accessory light on a car or a motorcycle, the return line is going to be through the body or the frame of the motorcycle. Occasionally you'll see an actual wire run back, but on a lot of applications, it's just the car body. So we'll show you Ricky's Pinto. Okay, here we are with Ricky Racer's 1971 Pinto. And of course, we got 12 volt car battery over here, represented by this 10-year-old gel cell. We got Ricky's dashboard. And Ricky went and drilled him a hole in the dashboard, put the frog light switch in, and he's got his brightness and darkness marked, so he knows which way to flip the switch after a few of his favorite beverages. And of course, we've got his frog lights over here. Ricky installs everything, hooks everything all up, and for the first 8 months, 9 months, things are great. We flip on that, we've got the frog light. We flip it off, it gets dark. Ricky's a happy camper. Then one fine, warm spring evening, Ricky wants to take his bestest girl, old Big Bertha, out and impress the young lady by doing some frog squashing. So they get out there on a back road, and they're going down the road, and Ricky says, "Let there be brightness." Oh my God, the lights didn't come on. Beth's disappointed, he's disappointed. Everybody's got to go back to the farm and drink a few more of their favorite canned beverages. So Ricky decides, I'm going to fix that. So Ricky goes down to the local auto emporium down there in Podunk Hollow, and he gets him a brand new fog light. After all, it's got to be light that's burned out. So Ricky installs his brand spanking new fog light. And he flips the switch. Still darkness in both positions. Okay, it's time to go back to the auto emporium and buy one of those brand new fancy-dancy $12 voltmeters. Them digital voltmeters. He'll be able to figure this out in a heartbeat. Alright, so Ricky's disconnected the light, and he's got his brand new voltmeter hooked up to the socket where the bulb plugs in. And he says, let's see what happens. And he flips the switch. There's just about 12 volts there. Now, accounting for losses through the car battery and the fact that my gel cell is probably running down, he says, nothing wrong with the switch. I must have another bad light. Ricky goes back and gets another new light. Still no joy. What the heck is going on? So then Ricky comes over here to the old radio mechanic and he says, "Radio mechanic, can you help me out?" He said, "I must have me a short somewhere because," and I love the word short. I hear this out of so-called mechanics every day of the week. "I must have me a short because I know the switch is good and I know the lights are new and I've got voltage there. How come my lights won't come on?" And I say, "Well, how do you know the switch is good?" He says, "Well, I've got my brand new digital voltmeter here that says I've got 12 volts coming out to the socket. The light should go on." That is when I break out my analog voltmeter. Now we've substituted an old school analog voltmeter for that brand new fancy digital voltmeter that Ricky bought. What Ricky doesn't realize is his new voltmeter has about 10 to 11 megohms of impedance. In other words, it doesn't load the circuit at all. However, this old school voltmeter is a 20,000 ohms per voltmeter, which means it draws some current from the circuit. Now when I turn on the switch on the 12 volt setting, we've got just a little bit over 8 volts. Now, that tells me I've got a bad connection and or a bad switch. It's real common for toggle switches on accessory equipment that you buy from the local parts place or Radio Shack. When they're trying to handle the current of 100 watts or more of fog light, it's very common after a few months of service for the contacts in that switch to get carbonized from the arcing every time you shut it up, turn it off and on, until they become a resistor. Okay, we return to our, as Big Clive would say, wee doodle. I love that guy's channel. You got to go over and see Big Clive. He's just so entertaining to watch. What has happened is this switch here is no longer a switch. This switch has now turned into a resistor of some value. It's because the contacts have become so damaged from handling the heavy current of the fog lights being turned off and on that it's passing current or voltage when it's read with that high impedance voltmeter, but as soon as you plug in a low impedance load like a light bulb or a low impedance load like that older voltmeter, it becomes quickly obvious that we're not getting 12 volts here. And if we backtrack very quickly and check our battery, sure enough, there's 12 volts there. And in fact, you could check from the car battery to this side of the switch and verify that when the switch is turned on, there's still 12 volts there. You want to check it under load. So let's do that. Okay, what we've done is we've taken our voltmeter, our analog voltmeter, and we've connected it to the side of the switch where the battery feeds into, through the meter into ground. So what we have here is the red leads going back to the power lead going into the switch, and this is our ground. This is our car body ground. And if we come over here to the meter, we can see the meter's all the way up full scale. We're on the 12 volt range. The batteries right now are recovered a little bit. It's a little bit over 12 volts open voltage. So the meter's all the way up to the full scale. I turn on the switch. We have our fog light connected again. Flip the switch. Nothing changes. We still have 12 volts going into the switch. So we can be pretty sure at this point that all of the wiring leading up to the switch is fine. So what do we do next? Well, the next thing I'm going to do is put my voltmeter on the far side of the switch here. We'll take this wire just connected there, and we'll see what happens when the switch closes. Okay, we've moved our voltmeter connection to the far side of the switch. That is the side of the switch where the light is. So now the voltmeter connection comes from the output of the switch through the meter down to ground. Now when I flip the switch on, the voltmeter shows absolutely nothing at all until I unplug the light. All of a sudden, we've got voltage. That's because the switch has gone bad, it's turned into a resistor, And when this low impedance load, like a light bulb, is put on there, the voltage drops to 0, or nearly 0. And with just the load of the voltmeter, it's reading 8 volts instead of the 12 volts we had on the other side of the switch. There's one of the very important uses for an older voltmeter with a 20,000, or even if you can find one of the really cheap ones. Some of them used to be 5,000 or 10,000 ohms per volt. And those are even more useful for an automotive setting for testing lighting circuits. Now, if you're testing computer electronics in the car, or you're going after the O2 sensor, you should never use one of these because you don't want to load the O2 sensor and burn it out. That is a case for a digital voltmeter. But when you're debugging lighting circuits or motors, windshield wiper motors, what have you, these things are almost indispensable. In fact, a lot of times instead of using a meter, I'll use a test light. And let me go grab one of those. Okay, what we have here is one of these old school test lights. It's got an alligator clip on one end. It goes up here. It's got a bulb, an incandescent lamp inside, and a pointy end, so you can check your different circuit points. You can actually pierce insulation with this if you want to. Now, if we put this directly across the battery, and this is going to appear a little bit dim because I have a 24 volt lamp in here. This used to be in my travel service kit so that I could work on our robotic equipment. Everything in the robotic system was 24 volt signaling, 24 volt operation. So I put a 24 volt lamp in here. But it lights dimly on 12 volts. Let's move the camera up here. Let me get my hand out of the way. And you can probably see, this is longer than the average one. It made it easier to reach down, but you can probably see it's dimly lighting up at 12 volts. It's a 24 volt lamp. If we were to put this on the ground, stick it on our 71 Pinto frame here, and measure the output. Let me swing this around. Alright, we use this to troubleshoot. And by gosh, look at that. It doesn't light up. It drops our voltmeter down because we're drawing current. But it doesn't light up. So in lieu of having an analog voltmeter, one of these is handy too. You can get these at any automotive store, and like I say, normally would have a 12 volt lamp in it. It's going to work the same way. It just happens to have a 24 volt lamp in this one because I use this for servicing on the road. So there's a good reason to own an old analog voltmeter and or a test light. So we sent our boy Ricky down, get a new switch. We install it in the 71 Pinto. We had to kick a few beer cans and some cigarette butts out of the way on the floor to climb up under the dashboard, but we got the job done. Uh-oh, what happened? This was working. I probably have a poor ground here somewhere. There we go. It was on the light. So now we are back in business. Ricky and Big Bertha can go out frog squashing, have them a good time, and all will be well down there in Podunk Hollow. So let's move on to another example. Okay, before we move on too far here, there's one more thing I want to touch on. It's my favorite rant, and I like to rant. Ranting can be fun. It can be kind of, calming. It gets everything out. They say stress is by holding everything in when you want to call someone an asshole. We're back to our circuit again. This time we've just redrawn it slightly differently. We've got our car battery. This time we have a 15 amp fuse. We have our brake light, or it could be tail light switch, either or. And we have our brake or tail light. Now in the case of the brake lights, it could be as much as an amp per bulb. So it could be a 2 amp total draw when the brake light switch goes on. The 15 amp fuse will handle that fine. If it's the tail lights, it's probably slightly less current because I think those are about a 15 watt filament. But at any rate, when you turn the switch on, the fuse won't blow because we're only drawing a couple of amperes through a 15 amp circuit. The circuit's here to protect the wiring from catching fire if something goes bad. In our previous example, we had a bad switch. The bad switch means the current is reduced. The light didn't turn on, nothing bad happened, the fuse doesn't blow, the wiring didn't go up in smoke. That is not a short. Just because something's not working does not mean you have a short. A short is a specific type of failure. So here we are again with our 71 Pinto, and you may or may not have pulled the carpet up along the edge of the body sometime, perhaps to run some speaker wires to the back of the car, and you found a whole bunch of wires running in that little channel right above the rocker panel. Those are typically brake light, tail light wires. But here we are again with our 71 Pinto, and we have to put some sheet metal over the rusted out rocker panels. So we run a sheet metal screw in, and while we're doing that, while we're running our sheet metal screw in, our screw goes up into the body and touches the wire, breaks through the insulation on that wire that's running down through the side of the car body. The next time we step on the brakes, the fuse blows. This, ladies and gentlemen, is a short circuit. It's so called because instead of the current taking the long path through the light bulb, it has now taken a shortened path, a short circuit, which draws excessive current. Now when the switch closes, because this goes directly to the car body and the screw doesn't have any resistance, we will draw the maximum amount of current that the battery can provide, and that's hundreds of amperes, limited only by this 15 amp fuse. Now if you do like some people do and plug in a 30 amp fuse, the wire here is usually only rated for 10 amperes. So the next time you step on the brake switch, you're going to have smoke and or fire in the car. Never overfuse something. If it has a 15 amp fuse in it, replace it with a 15 amp fuse. If it blows a second time and blows a third time, you have quote unquote a shortened or short circuit. That's what a short circuit is. If you're blowing fuses and or burning up wires, you have a short circuit. If the light simply isn't coming on, that is not a short. A short is a specific type of failure. Okay, I'll stop ranting and move on. Here's another very useful feature to have, or reason, I guess, another good reason to have an analog voltmeter. Easy for me to say. Let's say you were seeing readings that look something like what you're seeing right now on my very fancy-dancy, expensive Hewlett-Packard 3456A voltmeter. And you go, what the heck am I looking at? Am I looking at AC on a DC setting, or just what is going on? Well, if we move this guy over here and do the same thing, it becomes very obvious that the voltage is going up and down. It's not AC, it's just a fluctuating DC voltage. Now that could be in an automotive system, it could be a fan belt slipping, or if it's a piece of machinery, you could have loads coming and going, but it's very quickly obvious that the voltage is merely going up and down. It could be a bad connection somewhere. It's really kind of hard to figure out whether you're looking at AC or DC when you're seeing that happening on the digital voltmeter. But if we do this, it's suddenly very obvious that the voltage is merely drifting up and down for some reason. But then somebody says to me, but radio mechanic, I want some accuracy. Aren't those old meters very inaccurate? Well, I'm glad you asked that question. I am going to take this meter and compare it with this very, very expensive digital voltmeter. So let's go down here, and these old triplets, by the way, are absolutely spot on. This thing is probably 1950, this particular meter. It's the oldest one I have. It's been, it's been in service since, well, probably 1950 at least. Now I'm going to set this on 2 volts. Now, you've probably seen in the old movies in the airplane when the pilot's always tapping on the meters. There's a very good reason for that. These older meters do have a jeweled bearing movement. It's actually a pivot in a jeweled bearing. There is some friction. Some of the newer ones, like this guy here, have what's called a taut band suspension. This one happens to be the Type 5 suspension. And what it is merely a very thin piece of strapping or what's the word I'm looking for? It's a band. It's actually a band that twists instead of having a bearing. So those don't need to be tapped, but these older guys do. And it's something us old graybeards are used to doing. Now I'm going to set this as close as I can to 2 volts. That's right on the money. That's within 50 millivolts. Now how much more accuracy do you need realistically when you're working on a piece of equipment? I'm going to try to set this on 4 volts. Now these old triplets are accurate from one end of the scale to the other. Normally an analog voltmeter is rated for the upper third of the scale. They'll say the accuracy blah 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 at the upper 1/3 of the scale. These things are good all the way down the range, and I'm going to put this right on 4 volts and get it dialed in so the needle is right on 4. Come on, get right on there. Look at that, 40 millivolts. Let's try 6 volts. I'm going to put this guy right on the 6 volt line, 6 volt division. It's within 80 millivolts. That's really close enough for anything realistically that you're ever going to have to do. Again, we're on the 8 volts. Excuse me, I was on 6 volts before. We're on 8 volts now, 78 millivolts. Let's go up full scale. So you don't want to watch me do this all the way. Oops, overload. We're running out of range here. Let's go up the next range on the meter. I should have had it on auto range. Shame on me. Let's go up here to 12 volts and get it set on 12 volts. And by God, if that's not 12 volts, close enough to 12 volts, I don't know what your problem is. That's a good reason. Another good reason to have an analog voltmeter. If you work on old radios, on old-time radios, very often on the schematic it's going to say voltage is measured with a 20,000 ohms per volt meter. What they're talking about is one of these analog voltmeters that slightly loads the circuit. Back in the 50s and the 1940s, and when all these radios were new, very, very few service shops owned a vacuum tube voltmeter. Now a VTVM has about a meg ohm, or excuse me, 10 meg ohms or better of impedance. They're very high impedance meter. Very few shops back then could afford a VTVM. Most of your service shops relied on the old analog voltmeter. The servicing information in most of those old radios was intended for use with one of these, and it'll say voltage measured with 20,000 ohms per voltmeter. If you measure the working voltages or the operating voltages in the radio with one of these analog units, you're going to get correct readings. If you measure those voltages with a modern digital voltmeter or a vacuum tube voltmeter, something of very high impedance like this Hewlett-Packard, your readings are going to be high. And in some cases, considerably high. As you saw with the 12 volts, the difference between this meter and the digital meter was about 2 volts. No, it was more than that. 8? It was 4 volts. It was a 4 volt difference. This was reading 8 volts. The digital meter was reading 12 volts. That's a 4 volt difference. That's going to lead you down the primrose path. So if you service old radio equipment and the schematic says use a 20,000 ohms per volt meter, this is the guy you should be using to take your voltage measurements. Okay, so I'll stop ranting about that. Okay, and I don't want this video to go on for too long, and I'm sure you're sick of listening to me by now. Very briefly, I want to touch on a couple of things. This triplet model 630 it has been manufactured since sometime probably back in the 40s. This is probably a 1950s vintage one. It's a model 630. This is a model 630. This is a model 630. And this is a model 630. They have sub-variants. This is a PLK unit. This has an overload protection. If you over voltage this or over range this little button pops out. There's a circuit breaker in there to protect the meter. This one has the Type 5 suspension, and it says model PL instead of PLK, and it says Type 5 suspension. This is a standard 630 Type 2. This also is a 630 PL Type 3. So they come in variations. There's one that actually has a range doubler switch down below, which is very desirable. They're fairly rare, and I haven't got my hands on one of those. But I have found these to be the most rugged, other than the case. The case is Bakelite. They are somewhat fragile. The most rugged switch unit and the rugged meter movement. These are much better, in my opinion, than the Simpsons are. One last thing I want to do. This meter is an oddball. And this one has a clear back on it. You can see all of the workings inside of it. This is the only one like this I've ever seen. Now, I had one guy look at this and speculate that it might have been a salesman's model. I had thought originally it might have been from one of the prisons, because they used to make television sets with clear backs, clear Lexan or Lucite covers, so that the inmates couldn't hide weapons and contraband inside the television set. All the guard had to do was walk into the room, look at the television set, and you could instantly see everything inside. They didn't have to worry about things being hidden inside the television receiver. So I had initially thought that this might be something that was in a prison workshop, so that no contraband could be hidden in there, but I really don't know. Like I say, one guy thought it might have been a salesman's example. If anybody out there knows the reason for this having a clear back, and it's obviously from the factory, it has all of the features, it has the little feet, and you know, everything's identical to the black Bakelite one, but it's in clear Lexan, and this is the only one of these I've ever seen. One other thing I want to touch on very briefly, the high ohms range, the 100K range, these meters used to use a 30-volt battery, which is absolutely made out of unobtainium. You cannot get them anymore for the 100K ohms range on these. There's a real simple workaround. If you look down here, I have a 9-volt battery. There's another 9-volt battery, and there's a third 9-volt battery that I just have some Teflon tape on. These two are in heat shrink. I got lazy. I had some Teflon tape laying around and taped that one up. 3 9-volt batteries in series with the little snap clips, 27 volts, is more than close enough for the 30-volt battery. You'll have plenty of extra travel on the ohms adjust. It'll go completely upscale on the ohms adjust, and you'll have at least half a turn left on the knob here, so it's not a problem. And you can put these old guys back into service and not have to worry about the fact that you can't find that unavailable 30-volt battery anymore. With that, I'm going to close this thing down. If you thought any of this was worthwhile, please, down on the bottom, give me a thumbs up. You have to kind of minimize, and right below there's going to be a thumbs up, thumbs down, and I would really appreciate getting some feedback. That'll be all for today. We'll have something again next time. I don't know what exactly, but we'll dream something up for the next video. Thanks for watching, and see you again.